My student wrote this code, but with a little tweak, you can make it 5 times faster. His assignment is to make a regex library, which is, doesn't matter what it is, but the core idea, I was reviewing his code with him. I proposed, let's change the data structure, the main data structure, from looking it one way into looking another way. Let's see whether it will make the code faster. It's called AOS, Array of Structures into Structure of Arrays. But anyways, the student accepted it. It's like, yeah, let's go. He changed the code, made a bunch of changes, and reported to me. I got it 10 times faster. Now the code is 10 times faster. Most people will take the W here. What else can you do? You made your code faster. But no, the truth is, you want to drill deep down. So, I started comparing the branches. I started making the branches look as similar as possible. You want to single out the change that makes code run faster. I did it. What do you imagine was the outcome? My proposed change was not the source of the speed up. So, first of all, so when I got the branches as similar as possible, when the only change was the change of the data structure, the code ran the same. So that's another lesson. Not all optimizations make your code faster. But okay, then I started to think, what made the code faster if it's not the proposed change? Something in the other changes made the code faster. I started backing up. I started doing tweaks, step through step, and I find it. So we're going to go back to this code. What do you think is the problem? So we learned that the state is a kind of a beefy structure. It's not simple, you know. We have a vector and a bool in the set, bunch of things. What do you think is the problem? The problem was he made copies of this beefy structure. It's like when you're a librarian and you need to find a quote in a book. Instead of finding that quote and copying it, you make a photocopy of the whole book. It's crazy. You're copying a bunch of data when you don't need it. A simple, very, very simple change. Instead of copying the data structure, and look, it's very simple to make this mistake. You don't think about it. You just code. You have some state. You get it from the vector. You use it. It's fine. But no, just use a pointer. If you just use a pointer, the code is 5 times faster. So let me show you. Right, right now, I'm a clean all of the mess. And let's compile the thing and run the benchmark. But anyways, our code compiled, and it's it's quite slow. About 100 milliseconds. Okay. What if we use pointers? Let's see. Again, I mean, yeah, we have some incremental build. Let's see. That's a very nice improvement, and it's not a fluke, you can see. And mind that I'm also running OBS on the same computer, so those stats are even a bit skewed. I was getting 77 milliseconds, so 77 turned, oh my, into 17. Here the change is probably better, but it's like about 5 times. So simple. The lesson of today: don't copy the whole structure. It's very simple to forget that C and C++, there's ways to over overcomplicate things. You can assign a function of any complexity to an equal operator, to a plus. And here, you're making a copy of the whole structure. Don't do that. So remember, when you're iterating, when you're getting something out of vectors, maps, out of containers, it's much nicer and much memory friendlier to load only the parts you need. Because we'll only need transitions here. And here we only need whether we're accepting or not. So when our program compiles, the lookup will only take the memory needed, load the memory needed, not the whole big structure. So we improve the way we access memory. And CPUs today can do very nice predicting of memory access patterns, so this works very well. If you wanna be one of my students, you can join the program, link in the description. Bye bye.